You can speak anytime in between, or you can pick me on the chat window anytime in between, wherever you have any queries. While I'll share my screen, I request you to go one by one and introduce yourself so that each of us knows everyone else.
Sure. Miraj, this is Shekhar. I can go next.
Yeah.
So I started my career as a mainframe programmer and then I moved to web technologies. I have around 15 years of experience in web technologies. Currently, I'm working for a credit card company as a senior engineer, and I live in US.
So, any expectations, Shekhar? Although I know Shekhar personally, Shekhar, any expectations from anything special you're looking for?
No, I'll look forward for your expertise in big data. So my goal here is to diverge my career from Java J2E technologies, which expertise in to big data world. Looking at your expertise, I just wanted to join this session so that I can leverage and get a boost to my career, which I'm looking for. So,
Sure, definitely I'll try my best. Prabjeet?
all right.
Hi, this is Pradeep. Yeah, hi. So I'm having more than 8 years of experience, and my whole experience is mostly into Java technologies, like J2E. And I worked more than 6 years in TCS, and then I worked in Office Depot headquarters also in Boca Raton. So I worked around 2 years in US, and then I came back to India and I joined a company. The name of the company is Qantas. So it's a small company, like 100 people. So there, like I'm working as a technology lead, and I'm leading a team right now. Like basically, we are building a web application as well as an Android application for education domain client. And my goal is to update myself with this Hadoop and big data technology so that further I can, converge my career into this and take new opportunities.
Okay, so the good point is both of you are from the Java background, so we can go deeper on the Java side also, the MapReduce part of the Hadoop, which I normally
Okay.
do not go deeper side because people are majorly from non-Java background who attend the trainings. So, but the good
Mhm.
part is you both are from the Java background, so we can go as much deeper as you want on the MapReduce part also. Okay,
Okay. And my
so
current location is Delhi. So
yeah, I think yeah, I also talked to you personally.
yeah.
Yeah. So previously I picked your phones only. Yeah. So okay, just let me start sharing my screen. So so I hope you can see my screen, right? Okay. So if you are not able to see my screen, just ping me on the chat window. One minute. Uh, Let me share the whole screen as well. That's fine. Okay. Now I hope you would be able to see my screen.
Yes, I can.
Okay. Cool. So anytime in between, wherever you have any questions, just ping me on the chat window. So let me just quickly introduce ourselves. So we are basically a training. We mostly do online trainings. We have association of a lot of trainers with us, and almost all of the trainers are working in the real industry. So that's the only advantage which we have on other training online training institutes. So all of our trainers basically able to connect you to the real life experiences or expectations and experiences and technical problems which they are facing in their current industries. And all of them are working in the industry from last 10, 15 years kind of thing. So you get a lot of technical expertise from our trainers. So that is the major age which we have over the market. Most of our technologies are cutting edge technologies on which we provide trainings. We don't provide trainings to the technologies like Java or data warehouse kind of things or Oracle, those kind of things. Most of our technologies which you will see on our website are mostly related to cutting edge technologies or related to analytics words. So that's a very short about Design Pathshala. And thanks for choosing us. So let me walk you through the course details, and if you want anything other than this specific or any you want to do any changes, do let me know. I'll just quickly walk you through what is this, and I'll also make you familiar with some of these terms if you would have not heard about. So we'll start with what exactly is Hadoop, why people are basically using Hadoop, and why there's so much hype around Hadoop and big data world. Understanding the basic concepts, and thereon we'll walk on to the MapReduce program. So all of the Hadoop or big data world is basically done with the help of MapReduce. Although this world is changing extremely fast, each day there's a new technology which comes up, and these technologies comes as a wrapper on another one or a layer on another one and try to make your life as easier as possible. So people normally do not use MapReduce nowadays to write most of their stuff, and they probably use other technologies. I'll walk you through them. But if you understand the concept of MapReduce, it's very easy for you to understand other things because all of them are kind of wrappers around MapReduce. So we'll start with writing some basic MapReduce, and then we'll go into other deeper MapReduce programs. Thereafter, we'll look into Pig and Hive. So these are the two vastly used technologies in the Hadoop world, which people normally use to process their data. Hive is a SQL kind of processing language where you can write your queries like select star from table so and so, where so and so kind of thing. And Pig is a scripting language where we can write scripts somewhat familiar to another scripting languages, but it has on its own syntaxes. But it's also very easy to write as compared to MapReduce program. Then we'll look into Scoop, which is basically used to push in the data or push out the data from your RDBMS world or to the big data world, or push out the data from big data world to the RDBMS world. Then Oozy helps you to stitch up all these things. So basically, when you are writing your whole big data platform, or basically, developing a solution for any of the problem statements which you have for the big data world, you will be probably using a lot of steps. First, you will be scooping in the data, or you might be getting the data from different sources. So I'll walk you through all those things slowly and slowly. Then you will be processing your data. You might be creating your data warehouses in the big data world with the help of Hive and Pig, or you might be writing your MapReduce programs. And once you all of these steps are done, you might be scooping again out the data, process data, or you might be using some visualization tools to visualize your data. So all of these steps are stitched together with the help of workflow engine called Oozy. So we'll walk you through the Oozy, how you use Oozy to stitch up all these different steps into a single workflow, which you can trigger up or schedule up. Here's a beautiful UI from where we can, Prabjeet, can you make me the presenter? Prabjeet, why do you want to be a presenter?
Hello.
Yeah.
Actually, something wrong with my system, so I might need to restart. Like I don't know where I clicked actually.
So you know the problem. You don't want me to make you the presenter, right?
No, no, no. Yeah, like I'm just trying to close background, yeah, Skype and everything, but it's not letting me do anything. So I'm logging from my other system
Yeah,
so that
definitely.
I can
You can
restart
you
this.
can you can log in from any number of devices. You can even log in from your mobile. You can just download the app. You can even log in
Okay.
from your iPad or
Yeah.
anything. You can just download the app and just use this meeting ID. You can log from n number of devices.
Okay. Yeah, yeah. I'm just logging to my so that I can restart this computer. I don't know
Sure,
what.
sure, sure. You
Can
can
you
log
give
in
me
from
more
n
time?
number of devices. So in
Uh,
the meantime, yeah, sure. Okay. So thereafter, so we'll use a beautiful UI from where you can visualize all the data lying in your system and do a number of things. I'll walk you through that UI. And thereafter, we'll look at any of the data visualization tools like Tableau or Microsoft Excel 2013 to how basically the data which is processed up, how that data is visualized to do analytics on the data. And finally, I'll give you a project which will give you a kind of real-time feeling how the data is really used in this world and how basically big data is really used in the industry to do analytics or to do the data visualization or do the data processing. So it will give you kind of mixed blend of different things. And after completing each of these technologies like MapReduce or basic MapReduce, Hivepig, I'll also give you exercises which will give you a good hands-on on different technologies. So anything which you want to ask or you want to change anything or any specific comments?
No, I'm good. Can you hear me okay, Miraj?
Yeah, I can hear you.
Okay.
No, okay. Prabjeet might be joining in from other system, so I'll assume a yes from him.
yeah, I'm good. Yeah, I'm good. My
Uh,
other system is taking someone else's ID. So that's my boss ID actually. So I'm just trying to figure out how I can log out.
So you can use any of your even you can use a mobile device for today because today will not be doing any exercises. So today even you can use a mobile
Yeah.
device and you can just download the Android app or iOS app. Okay. So let's start. So basically, if you both are working for in the industry from last 8-10 years kind of thing. So I hope you remember the days in your colleges at least when you used to have a floppy disk of 3.14 MB, and that was much more than enough for us to carry our programs or data. And thereafter, there was a bigger floppy disk which was introduced around 5 MB kind of thing, and that was pretty good news at least to me that I can store 2 more MBs of data. So that was a world which we were living in, and it just not a decade away. And today's your laptops have more than terabytes of hard disk kind of thing, and that also is not sufficient to the people. So the data is growing each and every day, and it's data itself is becoming a problem for us. So previously it was just the users or operators who sit on the laptops or databases or PCs kind of thing, and they used to enter the data, and that was the only source of data generation in this world. However, as soon as the world is changing up, there's a lot of things which are happening in the industry. It's the users who started putting in the data. We are tracking the activities. We are getting the data from different machines and a number of things. And data itself is increasing at such a vast rate that it's difficult to manage it. And data itself is becoming a big pain for different industries or different people. So now it's not only the user generated data which is getting into systems, it's the machine generated data which is also getting into systems. So I hope you can guess some of these images which I've placed over here. The first image is image of weather forecast. So the satellites generate enormous amount of data, which we have to process up to figure out what is the weather today at California at 2 p.m. today. So to figure out the weather at 2 p.m. in California today, I might have to process last 50 years of data, or I might have to process some other locations or geography data kind of thing. So the machine data is a big challenge for us. Can you guess what is this picture doing over here?
Is data generated by the air traffic?
Uh, yeah. So a black box in a flight of Boeing 497 kind of thing generates approximately 1 TB data per engine in half an hour. So if there are 4 engines by default, that generates around 4 TB of the data in half an hour. So a flight from New Delhi to Bangalore would generate somewhere around 15 to 20 TB of data. So you can think of what is the kind of data which is generated by these machines, and if we have to figure out what could be an issue with the flight, or if we figure out the black box of mysteriously disappeared Malaysian airline kind of flights from their black boxes, you can think of the kind of data which we might have to process up. Hospitals again generating a lot of data from their machines or user histories kind of thing to figure out their medicines, treatments, and number of things. Walmarts generate more than 1 million transactions per hour. So these are the data which is getting generated, and so I normally give one pretty good example or a story which I normally speak out in every class. So there was one of the fruit vendor who used to come nearby my society, and I normally used to buy some fruits and vegetables from him. Suddenly he stopped coming up, and I also forgot up. And then I shifted to a newer society, which was almost near to my previous society, but around half a kilometer or 1 kilometer kind of thing away. When I went downstairs to buy fruits, I saw the same vendor. Asked him, "Hey man, you used to come to that society. How come you shifted over here?" So that guy was pretty smart. He gave me an answer that, "Sir, here I can see bigger cars standing in front of the houses. People have more purchasing power. People do not negotiate much, and I am able to sell more fruits as well as at higher margin." So that why was smart enough. His domain geography was pretty limited. His area of expertise was very, very limited. So he was able to figure out the best market for him. He was able to figure out where to sell his fruit, where he can maximize his profits. But if you can think of what if Walmart have to do the same kind of thing, what is the kind of data which they have to process up? So it's just their data warehouses are sitting with petabytes and terabytes of data on their data warehouses. So if they have to figure out or do this kind of analysis, you can think of what is the processing power which you require. So Walmart comes on different analytics. I'll share you different analytics which they come up with. One of the pretty interesting thing which I remember about them is they came out around 2 3 years back was if you put beers and apples together, sale of both the things increases. Who cares why the sale increases? But we know the sales increases, and they put beers and apples together. Okay, so these are the any questions? Anything?
No, I'm good.
Okay, so these are three V's of big data, which is what data which we talk about. So volume is the biggest problem with the data. The volume of data on which we are setting up today is pretty high. So these figures might be a little older, but I just wanted to give you a little glimpse about the kind of data which we are setting up with, and we have to process up for different analytics. So whole World Wide Web is setting up with more than 3 zettabytes of data. Facebook is setting up with more than 30 plus petabytes of data. This figure might be a little older. Walmart, just their data warehouse. I'm not talking about their real databases. This is just the data warehouse which they create out of their data warehouses and different data sets. And they're setting up with more than 2.5 petabytes of data. eBay setting up with more than 10 petabytes of data. So if these people have to do kind of analytics, it's not easier on their relational databases. They can just run up the queries and figure out what is happening, where the sales are increasing, what I have to do with sales kind of thing. They have to use the systems which can scale up at such levels as well as do a processing kind of these kind of things. The second major problem with the systems is the velocity. So it's not only the volume of the data, it's the velocity is the second major problem with the data, that the rate at which this data is growing up. So YouTube uh, gets 48 hours of new videos every minute. So if they have to apply YouTube kind of policies on the videos, if they have to figure out that the video is adhering to the policies of YouTube, they have to process 48 hours of new videos every minute, even faster than that, to apply or adhere the policies on the videos which are uploaded on the YouTube. Each minute we get 571 new websites. Facebook gets more than 500 TB of the data each day. People are tweeting more than 175 million tweets each day. Walmart, I talked about 1 plus million transactions each hour. So, and the another challenge is the rate at which this velocity is increasing. That is the acceleration of this velocity. The data which was generated in 2009, the rate at which the data was generated in 2009, this rate itself will be 44 times more in 2020. So it's not only the velocity, is the rate of change of this velocity is again a major challenge to the systems. And the third major challenge is the type or the variety of the data. We are getting structured data from the databases or the transactions which we do. We get semi-structured data from different logs which machines generate or user interactions. We have totally unstructured data from emails kind of thing, tweets, chats kind of thing. And all of the data need to be merged up, processed together to do different analytics on the data.
Miraj, can I ask you a very quick question on that YouTube video which you spoke about? So, how do they apply policies on the YouTube video? Can you give me some example about the policy of the YouTube video you're talking about, so that I can get a understanding of the data analysis done on the video data?
So basically, they are different. If you anytime upload a video on the YouTube, they just ask you different things that the video should not be, kind of adulterated kind of thing, or it should not be using anyone's else logos kind of thing, or you're not misusing anyone's logo kind of thing, these kind of things. So they process your videos before your video is basically made visible on your on their website. So whenever you upload a video, that video is processed the YouTube part before making it live. So they might be doing some image processing, video analysis, the algorithm which they are using up to figure out whether there is no content which might be uh, uh, though. So they might be they are applying basically video processing technology as the backend to process your video, and they would be having their standard policies which they apply on each video, which you upload on YouTube before that is made live.
Sure. Thank you. Got it.
Okay, so let's look at a few of the interesting thing how people are basically using this technology to. So basically, at the end what people want is either they want to increase their business or they want to mint the money. So how basically people are using this processing power of the big data or Hadoop to basically mint money or increase their customer base or these kind of things. So these are the major things which people normally do with the help of big data technology or data processing kind of thing, and they try to increase their sales or increase their revenues or increase their customer base. Predict exactly what customers want before they ask for it. You log into Facebook, you log into Twitter, you log into LinkedIn. They will suggest to the friends before you even search for the friends, because they predict from what you are doing or where what you are basically searching for, where your mails are coming from, different things, and they figure out who could be your friends. Similarly, based on the mails which we are getting up, Google will give you ads on the top. You search for any product on the website, or you search for any product, let's say on the Amazon, go on any other third them website across the web, you will see the same kind of advertisement or the advertisement for the similar product from Amazon or any other competitor of Amazon. Marketing campaigns, people are using highly this technology in the marketing campaigns which they are doing up, and that too with a targeted customer base. So right now I'm working with one of the biggest telecom in India, and if you have to send a notification for you, we can't just send a notification to each and every customer. We are setting up with enormous customer base, and we can't just send a notification to each and everyone. So we have to do targeted marketing so that the notification which you are sending to you is a notification relevant to you, and you would be taking some action on that. So marketing targets or marketing campaigns are targeted to individuals rather than just sending you bulk or spam emails. Improve customer services. People are using this technologies really crazily to increase their customer services. So the biggest pain point for customers traveling across the world or internationally with hopping flight is missing their baggages, or baggage get deported at wrong port kind of thing. So Delta Airline came with a pretty interesting feature. They came out with an app wherein they will give you a tag which you place on your app back. You click a pic of the tag from your app, and once you reach your destination port, you can track your bag live on your app. So although there might be the cases that your bag might be misplaced at some other port or might be deported at a halting port, but if you can see your live where your bag is basically at present, you might not be again and calling their customer care to figure out where is your bag, when your bag will be reaching, of kind of thing. So they're just, people are using this technology and a number of ways to increase the customer services or give you better quality of service. Fraud detection highly used in the banking industry. AML, anti-money laundering, is this field is vastly used in the anti-money laundering. So if to explain you what exactly is anti-money laundering, I've worked highly with anti-money laundering and implemented a lot of projects for Citibank and mentors for anti-money laundering. So I have pretty good knowledge about this thing. So basically, any of the transactions which happen in the bank or mutual fund or stock exchanges kind of thing, those transactions need to be detected by the bank whether they follow some rules and regulations, and those need to be, and if something fishy is figured out in any of the transactions, that need to be reported to the RBI of the corresponding country. And many of the times, so if you follow the financial news, you could see banks like Citibank or big giants pay millions or billions of dollars as a penalty if they are not able to figure out these kind of laundering transactions. So let's say I, as a customer, get a salary of 2 lakhs each month in my account. At some particular day, 50 lakhs is credited to my account, and next day they are just gone away. So there's something fishy in my account which need to be figured out. So there are patterns which are created up, and a number of things are done up, and people basically use big data kind of technology for anti-money laundering. So this is highly used in the banking industry. Get customer excited about their own data. People are, I don't remember the website name, but what they exactly do is they are basically seller of FMGG and food products. So they sell you the product, and based on what product they have sold you, they will tell you live on the website how much calories which you would have consumed. So if you are able to see the calories which you have consumed, and you can see your health chart kind of thing on the website, you are more intended to buy a product from the same website, because now you can track your calories and number of things from the website. So getting customer excited about their own data, identify customer pain points, solve them, reduce healthcare. So healthcare treatments, your whole health history there with the hospitals. They process your history as well as they do the processing of another histories, merge the reports kind of thing to figure out what could be your treatments. Social graph analysis is highly used. If I give you an example about myself, I brought a product from Amazon. Product was a little faulty. What I did is I just posted on their Facebook page. Within 30 minutes, I got a call from their team. I don't know how they did the processing of all the things. In just 30 minutes, they were able to figure out me, my number. They were able to figure out what is the product which I have brought up. I got a call from the customer care, and they told me that my product will be replaced. Don't worry about this thing. So companies are highly associated and very much in active on the social media. They don't want their social media or social images to be uh, you know uh, going down. They just requested me to remove the comment, and they will replace the product. So this is the kind of tracking which people do on the social graphs, and companies are highly, you know, I'm not getting the proper word. But basically, companies are highly monitoring the social graph because no one want their social image to be handed up because of any bad services or anything which happened. Research and development, Obama teams, different governments are using big data for different analysis, traffic analysis, mining, and a number of things. So basically, the purpose of this slide was to give you a little glimpse how and where this field is using up, and how people are using big data and technologies for at different areas to mint money or improve their business experience. Anything which you want to ask?
In the yeah, one question. So the example which you gave on Amazon product which you bought, and did you write the comment back on where you have the feedback, or you wrote it on Facebook that X product from Amazon was a crap?
Facebook.
Okay. So they monitored keyword like Amazon or whatever they would have done
So
it. So
So basically what happens in the backend is for Twitter, we get the streams for free. You can just subscribe on the Twitter based on the keywords, basically based on the hashtags, and Twitter will just send you those tweets. But for Facebook, you can buy it out. And so that the data coming through you almost near real time. You process it on the sentiment analysis based on the negative sentiments, and those are given points: high negative, low negative kind of thing. And high negatives might be personally monitored by some agents, or they might be there might be some alerts based on the product ID or order ID if you mentioned in the on the comment, and that's how that is basically at the backend monitored out.
okay, got it. So basically, Amazon and Facebook would have some kind of contract going on, saying that if there is a negative sentiment, strongly negative sentiment, we want to buy the data outright and do the analysis on it.
No, it's not the Amazon and Facebook which have a contract. Even you can log into Facebook developer account and you can buy the data from Facebook. Even there are a lot of companies which are mushrooming up in uh, California and southern India also, which are doing the similar thing, which will get the data from Facebook, or basically which will buy the data from different social websites for you, massage the data, and will give you a social graphs, or basically will track your social graph for you, all those kind of things. So the data is all you can buy the data yourself also.
Okay. So what you're hinting is basically Amazon would have got a third-party company who would be analyzing this kind of data for them.
So how
Maybe.
exactly Amazon is doing, I am not sure, but this is how basically people normally do up. So what is
Sure.
the contract which Amazon have, I'm not 100% sure, but
Sure.
practice something like this only they would be doing up, because the same
Sure.
thing
Sure.
I did for eBay when I was there with the eBay.
Mhm.
So as I've already talked about, Facebook sitting with 30 plus petabytes of data, LinkedIn, Amazon, so Trito. Basically, what they do is they use the medical data, medical history data to recommend you what could be your medical future and different things which they will predict you, or basically tell you for your treatments. Decoding a human genome used to take 10 years, few years down the line, but now it can be done in even less than 7 days. So this is the kind of processing power which you get with the help of big data technologies. JP Morgan, I told you, anti-money laundering. Okay, so there's a graph of which I've got from Wikibon. So this is a pretty interesting graph. There's a kind of there's an industry, big data industry. If you can see, the graph is not missing over here, or the number or the figures on at these years were too low that they are not visible on this graph. And you can see the rate at which this big data industry is increasing up is more than 1000%, and expected to be 53 billion US dollars by 2017. So this is the rate at which this industry is increasing, and you can log into any of the company's website. You can see one tab just highlighting on the big data analytics. On any of the service companies, technology company, you just log into any of their website, and you will just see one of their tab is these is highlighted just on the analytics or big data or similar technologies. So these are different job options or opportunities which you could look at. I would not promise you to make you any of these things. You have to personally, mushroom yourself, massage yourself. I can help you up to reach your goal, but you have to personally do all your homework to reach any of these goals. So this role I'll not suggest for you. Based on the training which you are joining up, I would suggest you for both of you based on expertise to this role. But this role would require a lot of hand burned as a Hadoop developer. So I request you to do a lot of practice on the examples which I'll be sharing with you, the exercises which I'll be sharing with you, and some of the personal homework to get expertise of the real problem which people will get. And I would suggest you to target for this role. Data scientist is a totally different role which we are not targeting in this. Basically, this training program is not intended for this thing. So data scientist is a mixture of I won't say it's a mixture of, but it's a little different stream where people use machine learning, R kind of thing, or similar things to look at the insights of the data, or basically run algorithms on the data to figure out different things from the data. Big data platform will give you the processing power on the data, will give the technology how to run those things. You have to apply your algorithms to figure out different analytics on the data. So data scientist is a different role, and administrator is a totally different role, which I think you both are not suitable based on your profiles. Any specific questions over here?
No.
No. So we have courses on R and similar things also, machine learning, R, all those things. But those are totally different. Uh, not totally, but little different from what we'll be discussing about in this program. So these are different salaries. If you want to look at, you can look at a slide later on. I'll share with you. Your salaries in US, median salaries. I got these from different things. So these are different companies who are highly used recruiting up. Okay. So let me walk you through the little history about Hadoop and big data, how these things came in picture, and then we'll move on to the real things. So basically, around 2004, Doc Cutting was a guy who used to manage a product called um, what is the product name? Um, Lucene and um, Apache Lucene. How can I forget the name? Uh, oh, how can I forget the name? I'm just missing out the name. So this basically there were two products from Apache. One was Lucene, which was child project of not- uh, I'm forgetting the name. I'll recall the name in a minute. So basically, that product from Apache was an indexing engine. So basically, what that does is Notch, not Notch. I'll recall the name in a minute. So basically, what that does is that basically indexes your words on your text files, and your searches on the text has become extremely fast. They started a product called Nudge as a child product, where they basically wrote a web crawler. So their basic purpose was to create something like Google. Web crawler will crawl the whole web, World Wide Web, and Lucene they will use for indexing. Yeah, the product was Nudge and Lucene was the product. So they will use the Lucene for indexing, and they were trying to create something similar to Google. I don't. And dog cutting was the guy who was heading this whole initiative. But when they figured out that if they have to index the whole World Wide Web, the kind of infrastructure which they will be requiring up would be extremely high. And the cost of maintaining the infrastructure was, if I'm not wrong, was around something less than $1 million each month just for the maintenance. But as that was pretty ambitious project of Apache, that they got a go ahead, and that project started up. But just 3 or 4 months down the line, there were issues which they were facing up with the vertical scaling of the systems, and they had to stop. At the same time, Google came with a white paper called Google File System. Dog Cutting wrote that thing and implemented something called MapReduce and SDFS, which became an open source later on. And that's from where Hadoop came in picture. So the beautiful yellow color elephant which you see of Hadoop as a picture, that is basically a toy of this guy. Sorry, the toy of sons of this guy. That was his favorite guy, favorite toy of his son. So he gave that as a logo. And later on, dog cutting was hired from Yahoo, and I hope you understand the reason why Yahoo hired dog cutting. And most of the Hadoop related development was done in Yahoo. So different technologies which you're talking about, some of them are also developed in Yahoo. So I'll walk you through those things. But Nudge was the subproduct, which if I'm not wrong, I'll cross confirm it in a minute. So let me walk you through a very simple mathematical problem. Let's say this is one machine. I have 1 TB of data sitting in this machine, and 4 IO operations which are possible on this hard disk, and 100 Mbps is the speed for each IO. I'll just put you on the mute. Okay. Let's say I have a machine with one hard disk, and this is a normal SATA hard disk which has four IO operations and 100 Mbps is the speed for each IO. If I have to just read 1 TB of the data, can you do a quick mathematical calculation how much time I would be requiring just to read 1 TB of the data? Any answers?
Hear you a bit for a minute.
Yeah.
Repeat the question.
Okay. So what I'm saying is this is one machine with 1 TB of the data. which is lying on its hard disk. Hard disk is connected with 4 IOs. Each IO is capable enough of 100 Mbps. That is the normal SATA speed, which you normally have on your laptops or desktops. So this is a normal machine with 120 TB of the data. I have to just read this 1 TB of the data. So can you do a little quick mathematical calculations? How much time do you think I would be requiring up just to read this 1 TB of the data?
It'll be 1 TB divided by 400 Mbps, so it'll be around 40 minutes.
Yeah, 40 to 45 minutes. Yes. And yes, the project name was Lucene only, and the sub project was Nudge. So Lucene is a web and text indexing, and Nudge is a web crawler. Uh, and dog cutting was heading Lucene, and later on Nudge was started a sub project inside Lucene only, which dog cutting was heading up, and thereon he started Hadoop as a project.
So can you give us a little bit more background on what was Nudge project doing and how did Lucene
So okay, okay, sure. So Lucene is a web indexing project from open source project from Apache. So basically, that indexes your text, and your as it indexes your text, your searches on the text or any of your files becomes very fast because the data is indexed. Then they started a project called Nudge as a sub project inside Lucene. Nudge was a web crawler. So basically that crawls your website, and if any reference of another website finds on your website, that goes to that website. So there's a kind of web crawler which they have written up, which do nothing but crawls your website and writes your data onto their databases or data sources what they were using. So Nudge is a web crawler and open source, again open source from Apache. So Nudge was crawling the web, Lucene was indexing that web, and they were trying to create something similar to Google.
okay.
And that's the reason dog cutting was later on hired from Yahoo also, because these are the biggest rivals.
Sure.
So it's approximately 45 minutes, which I would be requiring up just to read this 1 TB of the data on my laptop. So this is a normal SATA speed. Now there is a kind of benchmark what should say, a meeting or benchmark different competition which happens up. So previously Google had a record of sorting 1 TB of the data in 297 seconds. Here I'm saying sorting, that means I am reading the data, I am sorting it and rewriting the data to the hard disk. So 1 TB of the data has been read from the hard disk, sorted and rewritten to the hard disk in 297 seconds. However, on if I'm using the for this normal machine, I am requiring 45 minutes just to read 1 TB of the data. I request you to go on mute. So however, Google not only read the data, sorted the data and rewritten that to the hard disk in just 297 seconds, approximately 6, 12, 18, 20, 4 or 5 minutes. Later on, that record was broken up by Yahoo in July 2008, and they not only read 1 TB of the data from hard disk, they read, sorted, rewritten the data in 209 seconds. However, we require 45 minutes to read the data. So what they did is they use a cluster of machines. So I hope you understand a term called horizontal scaling and vertical scaling before I go ahead. If no, just ping me right away, otherwise you will not be able to understand anything.
Can you explain that a little bit more?
Sure.
Scaling part.
Sure. So basically, uh, vertical scaling is something where I scale my systems vertically. That is, if let's say I have a 8 GB RAM in my laptop, I want to increase, or I want to increase my processing power, or my laptop is hanging a lot. What I'll do is I'll buy 8 more GB of the RAM, and I'll make my system more upgraded to 16 GB RAM. That is a vertical scaling. That is, I'm scaling the single system vertically. I'm adding and adding resources to my single system, but there is always a limit to the vertical scaling. And moreover, vertical scaling is very costly. If you go to the market to buy a laptop with 128 GB RAM, that would be costing you more than 2,000 or $4,000 USD. However, you go to the market to buy 8 GB RAM, 8 GB RAM kind of laptops, or 16 GB RAM kind of laptops, and you can buy 16 into 4, say four such laptops in less than $1,000. So vertical scaling is extremely costly. However, similar configuration in horizontal scaling is very much cheaper. So rather than buying a 128 GB RAM laptop, I can buy 16 into 4 laptops that will give me similar kind of RAM. So that is a horizontal scaling. I buy 4 such laptops or devices, associate them to a network, and then I process my data parallelly on them. So this is horizontal scaling. We keep on adding resources horizontally to the network or to the cloud. However, vertical scaling is a scaling where you scale your hardware or single hardware. You keep on adding resources, but there is a limit to that. And that's the reason in the previous example which I gave you regarding the failure of the nudge project, or basically the web crawling which Apache was doing, was a similar thing, only because at that time the horizontal scaling concept was not there, and the horizontal scaling processing, either SDFS Hadoop kind of thing, was not there. So they tried to vertically scale their systems, but there was a limit to the vertical scaling. And after that limit for these, they were not able to process the data. They were not able to index the World Wide Web, and that's the reason that got failed. And later on, they implemented Hadoop as a solution. So does that make sense?
Yeah.
Okay. So what they did is they use a cluster of machines. They use 910 machines, 910 nodes. Each of those machines were similar to your laptops, even lower grade than your current laptops might be. They were 6 GB RAM in each of the nodes, and those were quad-core processors. So they use 910 machines to process that data, and how they were able to achieve that thing in such a short span of time. Here's a solution. So let's say rather than putting my data on a single disk, whole 1 TB of the data on a single disk, what I'll do is I divide that data into 10 machines. So each machine is having 1/10 of a TB of the data. Now if I have to read that data, I hope you know the answer. How much time I will be requiring up? It's just 4.5 minutes. Similar thing they did is they divided that 1 TB of the data into 910 machines. They read that data, processed that data locally, and just process and just imitate the output. So that's the reason they were able to achieve that thing in such a short span of time. Does this thing make sense to you? A quick yes or no will help me. Shikhar, Prabjeet,
Yeah. Yes. I understood.
Shikhar, got it? Okay, might be he might be away.
Yes, I am good with that.
Okay,
Yeah, I
okay.
able to
Fair
hear
enough.
me in between.
No, actually, I placed you on mute. You can unmute yourself whenever you want to speak up. I placed you from here on mute.
Okay, but can you hear me now?
Yeah, I can hear you now because I
Okay, so
unmuted you. I thought you might not be muting yourself, unmuting yourself, so I unmuted you. Okay. So now the another problem is if I put my data to 910 machines kind of thing, who will know where the data is lying up? Which data is lying where? So basically, let's say I have my data on the 4 machines. One machine is having design partial projects. One machine is having design partial images. One machine is having design partial websites. One machine is having design partial softwares. Who will remember which data is lying where? So there's something called main or master node in the whole cluster, which manages your whole cluster so that knows where your data is lying up. So you interact with your master machine or name node. Don't worry about the technicalities of the system. You interact with this machine that I want my projects. So you talk to him with the namespace. This is my namespace and my directory. Give me the data associated with this thing. This machine will then talk to this machine and will get your data. So there's something called master in the cluster that is called name node, and that is what knows where your data is lying, on which machines, on which nodes your data is lying. So basically what you do is you do horizontal scaling the cluster. Your data is divided across horizontally in the cluster, and do the processing of the data locally, and you just send the processed data as an output. That's the reason you are able to achieve such a high processing power in the cluster. And the beauty of the whole cluster is you never transfer your data. If I have to transfer this data to the master machine, this whole 1 TB of data over the network, you can see I'll just be lost away with all the problems. Basically, I'll be again hitting my head with all the problems rather than lost away. So you do the data processing locally. You just send the processed output that will be much smaller as compared to your data size. And your logic would be again very smaller because your data processing logic would be a few MBs kind of thing or even less than that. So you transfer your logic to each and every node. The data is read on that node and data is processed locally on that node. How that is done, don't worry about those things. How your data is divided, don't worry about those things. We'll talk about each and everything in detail. Okay, so that is just an idea how the things happen in this world. We'll talk about each and everything in detail. So let me tell you the cluster sizes which companies are using up. And these again figures are older, 2013 figures. Yahoo setting up with more than 42,000 nodes cluster. LinkedIn using more than 4,000 node cluster. Facebook, this figure is older, 1,400 nodes kind of cluster. So these are kind of clusters which people are using up to process their data, and that's the reason they are able to sustain their petabytes and zettabytes kind of data or data warehouses, and they are able to do analytics on the data. Okay. So by now I've also explained you little things about the Hadoop, but this is a definition of Hadoop. Although you will not see any other definition in my none of the slide, but this is what I wanted to tell you. So, but do you want to explain me this? What is the? Now I hope you will be able to understand this whole definition. Commodity computers are computers which are used in the cluster that is pretty low grade machines, and that's the reason they are called commodity computers. So can you explain me this definition? Are you able to understand this definition now based on the things which I have explained you till now?
Yes.
Do you want to explain it?
Sure. So Hadoop is a framework which is allowing to set up process a large data uh, through parallel processing through smaller capability machines which are called and which is into a cluster or network of computers which is centrally managed by a master computer.
Yep, perfectly fine. So that's what we are doing. We add commodity computers which are much cheaper to buy. And even if they fail, we don't worry about that because of the way this technology is all running up. I'll explain you those things. And large data sets sit on those clusters of machines distributed across the machines. We just transfer the logic which you want to apply on the data. That logic is applied locally on that machine. That the process output comes from the machine. The process output then comes to a central machine and displayed to you. How that happens in a deeper, we will look at each and every detail. So Hadoop is an open source implementation of Google papers, white papers which were published up. It's based on a simple programming model which is called MapReduce. So all your code which is running up in the Hadoop clusters is basically a MapReduce. Even if you use technology like Pig or Pig, Hive, Scoop, at the backend they will be converting those things through the MapReduce only, and at the backend on your data the MapReduce code will be running up. And it's designed in such a way that your any kind of data can fit into the cluster. So you're not worried about, or you don't have to think about that whether my videos will fit in the cluster or whether I'm able to put in the audio or text file kind of thing. The whole framework is designed in such a way that any kind of data fits in. Okay. So before I explain all of these things, let me tell you few more things. So as I told you, this is a cluster of commodity computers. So the problem with commodity computers, or basically the problem with any of the hardwares, is you can't stop hardware from failing. Do whatever you can do, but hardware will always fail. So Hadoop is designed in such a fashion that even if there are failures on your machines, or basically your commodity computer fails, one or two commodity computer fails, or a few of the computers in your network fails, your data is never lost. If you are running some processes, those are never lost. If you are doing some processing, those are never lost. You get your output. How? Just wait for one or two more slides. I'll explain you. Scalable, because you are able to add your machines scalably horizontally across the cluster. Whenever you want more machines, you just add on more processing power. You just add on machines, and you can do more processing, or you achieve more processing power on the cluster. So that's where elastic, if you've ever heard about elastic clusters or AWS elasticity kind of things, so that's where elasticity comes in picture. Whenever you require more processing, you just add on nodes on the fly on a cluster. You use their processing power, and later on when your load on the cluster is down, you remove the machines. Economical, because I have all the commodity hardware, cheaper machines which are added as a node to my cluster. So it's very much economical, efficient, because your data is divided across the machines and processed locally over there parallelly. It's efficient, reliable, because even if some of the nodes are failed, your data is never lost, your processes are never lost, because your data is replicated in the cluster. So your single copy of the data is lying at more than two places. Normally is by default is three. So a single copy of the data is lying at three different nodes.
How do you make it stable?
And that's the reason you, even if one of the node dies up, you have a copy of your data at least in another two nodes. How that is maintained, I'll explain you in detail. So does these terms make sense to you? Scalable, economical, efficient, reliable?
Yeah, definitely.
Okay.
I'm a little bit concerned about reliable part of it. Maintains multiple copies of data. That's fine.
So basically, your single file is copied at least three times. So even if some of the node fails, you have a copy available on some other node, and the process starts on that node rather than on the node where your data which is basically failed up, died down. How that is maintained, I'll explain you. Fine.
Yes.
Okay. So that's the thing which I was saying you. It's based on the assumption that hardware will always fail, and that's how it's made reliable. Even if the hardware fails, our processes we are never failed, we never lose the data. This is the most important thing which I hope you should remember and you should put in your heart. It's based on assumptions that as you are dealing with big data, as you are dealing with petabytes, terabytes of data, you would be writing the data once and reading the data many times to do different analytics on the data or do that or basically using the data for different purpose. But you will be writing the data once. So these systems are not meant for kind of updates or deletes. You will not be able to achieve them. These systems are meant to write your data once, dump your data once, or keep on dumping your data and use that data or basically read that data many times or process that data many times. Another problem is data transfer and IO is a bottleneck. So uh, data transfer across the network as well as IO or basically disk reads and writes are bottlenecks the system. So they are trying to optimize that. How? I'll explain you later on. Then you should not be keeping smaller files or I put 1 million 1 MB kind of files. I should not be putting up these kind of files in the system. These systems are meant to put files of higher sizes or bigger sizes, GBs kind of thing or petabytes kind of things, rather than putting up your MBs kind of files. Then it assumes you're using commodity hardware, so these systems are meant in such a way that even if there are some failures or kind of things, those are automatically detected, and systems are basically uh, automatically they can handle your failures and they can transfer your loads to different machines and they are always up and running kind of systems. And rather than moving the data, you move the logic, which is very, very, very small in the size, and that's the reason you are able to achieve those kind of processing powers. Any questions?
No.
No. Okay. Okay. So in this slide, I'll explain you how the data is divided across the network. So just wait for 2, 3 more slides, and by the time I'll again give you other technical terms. So as you would have heard from me, name node. So name node is the master of your cluster, which manages your whole cluster. Name node is the node which knows where your data is lying, which data is lying where. And the green color boxes which you are able to see down are called your data nodes or the commodity computers or commodity hardwares or the cheaper hardware, whatever you want to call it. Normally it's called commodity machines, and in other words they are called data nodes. So these are all your data nodes which are connected on the cluster, and there's something called master called name node which manages your whole cluster. And sometime name node can go down, though say something called secondary name node. Although this is a picture of Hadoop 1.x. In 2.x there are some differences. I'll explain you what are those differences, but I don't want to confuse you everything on the first day. So we'll be talking about a lot of things. What are the changes in Hadoop 2.x world? But I'll explain you first what is 1.x, how 1.x is technically working, and then it would be much easier for you to understand what's happening in the 2.x world. So in 1.x we had a secondary name node which takes care of the system if name node goes down. However, there was physical intervention required in 1.x. If name node goes down, secondary name node has to be physically made up. That was the problem with the 1.x that has been resolved in 2.x architecture. How will I'll explain you in 2. When we'll be covering up 2.x yarn architecture. But for the time being, just remember there's something called name node, there's something called secondary name node, and there's something called data nodes. Name node is the master of the cluster. If name node is down, nothing can be done in the cluster, and that's the reason so there's something called secondary name node in 2.x that is automatically handed over if the name node goes down. In 1.x, that need to be physically made up if the name node goes down. So secondary name node contains all the data which is lying in the main node and contains all the state of the cluster, which machine is having which data. Name node or secondary name node never do any of the data processing. These machines are just meant to help your cluster running up. All your data always lies on your data nodes, and all your data processing happens on your data node. Do you want me to repeat, or does that make sense? I am not going deeper. I'll be going deeper slowly and slowly, very slowly. But on each and every slide, I'll introduce you with one or more technical terms. Any questions over here? Name node, secondary name node, or data nodes, their roles and responsibilities. I'll again explain all of those things in detail later on. But any questions over here right now?
Miraj, I have a small question. So when the client requests to read a data, so does it say that if I want to, from your previous example, that I want to read an image from the previous slide which you showed, uh, there were 4 servers and images were one of them. So does the client first interact with the name node to say I want to read an image, and then name node, this is the server you want to go back to read the name node, so to read the image, and then it goes to that image server. Is that what the sequence is?
So basically how the read happens is, whenever I as a client want to read some data, I interact with there's a slide which I'll be talking about. This is 49 number slide, but as you've raised the question, let me explain you. I as a client talk to name node. I want to read this data. Name node tells me where this data is lying up. I contact to that data node and read the data.
Okay.
But that all happens at the backend. Basically you as a user just write a command. Everything happens in the backend. Everything is transparent to you. But this is how internally in the cluster happens.
So say suppose in for giving example, we say read file input stream, and you give
Shikhar,
the
when
file
you
name.
speak, sometimes there is a little disturbance or lag in the voice. Same, do you hear from me also, or is just
Now,
when you speak? Sometimes your voice just missed out. Does my voice also miss out?
sometimes yes, I do hear it, but I could still figure it out.
Okay. Then in that case, I have to put in the broadband cable. Rather, I'm using Wi-Fi. Sometimes it happens with Wi-Fi. That's the reason I was asking.
So what I'm asking is this. I'll repeat the question. So say suppose if a client says, giving a Java example, that in Java what we do is we say that read file input stream, and you give the file name, right? So it physically goes to that file location and starts reading the file, right? So here when you say read images, so you would give the domain name of that, and then you get the data from the data node.
Yeah, so I'll give the domain name slash folder and the file name, and that whole path will go to the name node. Name node will tell me where this exact file is lying up. Although that there is never the file which is talking about. I'll explain you in detail. But for timing, just
Okay,
assume that is the file. So then I as a client will go to that data node where my file is lying up, and I'll read that file from that data node.
okay, all right. I'll
But
wait for
normally,
that.
but normally you don't read the whole files because this is a system which is meant for processing the data, and you will never be reading petabytes of the data, or kind of thing. So usually, although all of those queries will be, I understand the queries which you are having up, and those will be cleared up. So, but that answers your question a little bit, yes.
Yes, thank you.
Okay. So these are systems which are meant for basically read write once, read maintains, as I explained to previously also. So normally when you are putting up your petabytes files of size of petabytes or terabytes, you would never be reading or displaying those files. I created a file into stream and then read that file kind of thing. You would be rarely doing those kind of thing. What you're doing is you would be processing the file. You would be running some queries on the file. Let's say I've placed a file of or a dump of employees data. So I'll just later on will be running up some queries on the data select from employees where employee salary is greater than so and so and those kind of things. So at the back end, yeah, the file would be read up, but you as a user would not be reading those files and displaying those things because that is not possible with such kind of big files. So practically you'll not be doing it, but definitely technically you can do it. Then you can't delete or modify the things as I explained you previously also. So you can append to the existing file. You can't modify the things. However, you can delete the whole file and you can rewrite the appended or new file. Data is divided into blocks. Interesting thing. So basically, what happens up is, as I was telling you, Shikhar, you will never be interacting with the name node in terms of files, rather than you will get the information about the blocks. So basically, when I as a user put some file of let's say 1 GB, that file is divided into smaller blocks, and those blocks are placed on the data nodes, and name node has the information which are the blocks associated to the file and where are those blocks lying up. So file is divided into blocks. These blocks are placed onto data nodes. How those blocks are placed, I'll explain you in this slide. Intelligent client. Yeah,
Can you tell me one more time? Write once, read many, access model. That statement, can you just,
yeah.
and client can only append the existing files. I just wanted to get a more clarity on that one.
Okay, okay, okay. So the system is meant or designed in such a way. I'll explain in detail why that is technically not possible. Why that is technically not possible to append or basically modify the things on this slide. But what I'm saying over here is, yeah, like I can open a file and let's say I have a file on my Windows machine. I open the file, change some text, save it back. That kind of thing is not possible. So you dump in your data once, you can read the data as many times as you want, but you can't open the file and modify it. You can delete the file and rewrite a similar file with the change structure or change data which you have done, but that is possible with the delete and again insert. You can't open and modify kind of things.
Okay, I got it.
And the client can only append to the existing file. That's the same thing. You can append to the existing file, but you can't modify it.
But
So
is it not the same thing?
Sorry.
Is it not the same thing basically because file?
Okay. Technically, a little different. Okay. So basically, okay. So this is my file. So let's say I am getting each day a dump of some of my data sets from different systems to my SDFS as a cluster. So this is my SDFS cluster. Okay. So in the first point, what I'm saying is the system is created to write once, read many times. So first day dump came to my system, I can read it many times and do the processing on the system. Again, next day data come from the same employee table. So what I'll do is I'll add that data to the same folder, but I can't add that data to the same file. I can't open that file again and add that chunk of data which came today. I'll append that data as a new block to my file, and that block information will be added to the file metadata, and my name node will know that new block is appended to this file, to this folder. So that's what I'm trying to say. You can append the data, but you can't open the file and kind of do the modification to the files.
Your employee table had got 1,000 records, right? You wrote that those 1,000 records in 5-7 blocks.
Yeah.
Now, next day what you got is 100 more updates
Uh,
on those 1,000
So
records.
let's say each block was of, let's say, 200 MB, but this block, last block, was just created of 10 MB, and rest of and 190 MB was not utilized. So practically,
Okay.
I can't reopen this block and write those new 100 MB data which came to me. I can write that to the new block only.
Oh, so you don't mean to the entire, oh, you mean within a block, basically. You don't mean the file itself.
Practically, you can't append the files also. When I'll show you the system, you will able to get it. But
Sure.
practically, you can't append the files also. Technically, not possible.
Okay, I'll wait for it, that slide to come in.
Yeah, I understand the questions coming up, and that's really good. You keep on asking up, but you will get the answers. I'll not miss any of the questions. Okay, so basically, this is a graph which I wanted to show you before you move on to or drive into the Hadoop world. So people just blindly start using the things which might be over engineering or over solutions for some of them. So this is a graph of traditional databases, and this is a graph of Hadoop world. So for smaller data sets, this is not a technology. There's always a intersection. You have to figure out this intersection based on your project, based on a complexity of algorithm which you're running up, based on complexity of data which you have, based on the size of data which you have, based on the cluster which you have, based on vertical scaling power which you have. And based on this intersection, you should think of whether you should move to the Hadoop world, or you should still be using the traditional databases. After a point, your traditional databases will give this kind of performance, but Hadoop will give you almost flat or horizontal kind of performance. That is, the response time of the query is almost same or will not be much higher. But there's an overhead with all the queries or all the processes which run this Hadoop cluster. I'll explain you how the process runs up, and then you'll be able to understand why there's a lag of this kind of time between traditional databases, kind of Oracle or MySQL, and Hadoop world. So you have to figure out this intersection and then only move to the Hadoop world. Based on the data sizes, you have to figure out on your complexities. But there's traditional databases are much faster if your data sizes are smaller in terms of just on few GBs kind of thing, or in depend again on the data size and kind of data which you're using up. So again, you will be keep on hearing these terms. I wanted to again bring it to the picture. So there are different flavors of Hadoop which are available in the market. And Apache, the vanilla flavor is basically, different companies change it little bit, or add on their components, merge and marry different open sources of Apache together as a platform, and publish them or distribute them. So these are the implementation of Apache open sources of Hadoop. Hortonworks, Cloudera, Mapr. These are proprietary solutions, Pivotal, HD, and IBM. These are different flavors of Hadoop. The program which will be using up, the queries which will be writing up, the technical programs, MapReduce, Hive, big kind of thing which will be writing up. You can run it of any of these things. Those programs will not change. However, the way these things are packaged up, way these things are distributed up, these are different. There are differences you would see. These two are highly used in the industry, and you would be seeing 99 or 98% of the clients are using these things only. Horton Muscle Cloudera, because these are open source and much aligned to the uh, Apache's open source implementation. We'll be running all of our programs queries on Hortonworks flavor, which I'll share with you. If you want to run into any of these things, you are most welcome. You can just download them and use them. Most of your program will not change. There might be little changes, but in 99% of scenarios, there won't be any technical changes in your programs which will run up. Anything over here before I move on to the next slide?
So is there any difference, like major difference?
I
Like,
think you are
is there
logged in
any
from.
major difference, like on these flavors?
Uh, Major difference. So they are packaged. There are different things which are packaged together. Cloudera gives you some native things like Impala. Hortonworks has their own implementations like Nox. So I'll talk about those different technologies. But as such, for the native things, MapReduce, Hive, Peg, Scoop, no. Hive, Peg, Scoop, Oozy kind of things, there is no difference. All are same. Then there's a green plump and other things in Pivotal, which is their native implementation. So all of these flavors are all of these companies have, each of them want to market their system as the topmost. So they keep on adding new things or changing few of the things. But what is normally used in industries is the Hortonworks or Cloudera, widely used. Although you will see implementation of these things also, but widely used is Hortonworks or Cloudera only. So there are a lot of technologies which are packaged together. I'll tell you most of them, but each day new things comes up. But I'll tell you most of them. What comes with Hortonworks, I'll show you. What comes with Cloudera, I'll show you. So this is not covered in the basic slide. I'll show you in the advanced slide what comes in the Hortonworks and different things which comes with the Hortonworks flavor of the Hadoop. There are a lot of technology which are added together to make your whole platform. Make sense? Or do you want me to go a little bit more deeper? I can go right away. There? Prabhajit, are you there?
Yeah, maybe you can continue further. We'll discuss afterwards.
No, I have the slides on those things, but not covered in the basic part.
Okay.
Okay. Okay. So once you understand this thing, I think Shekhar, some of your queries which you were asking up would be cleared up. But still, if you have another doubts, please keep on asking up. So let's say I have a file. Let's say I have a file which is of let's say around mm, let's say around 300 MB kind of thing. So whenever you put on your data or file into SDFS file system, your file is divided into blocks. In Hadoop 1.x, block size is 64 MB. Everything is configurable in this world, so you can change the block sizes. By default is 64 MB. In Hadoop 2.x is by default 128 MB block sizes. Again, it's configurable, you can change it. How you can change this, their configuration things which will cover in later on classes. So all of your files are divided, all your data is divided into blocks. So here in 1.x is divided into 64 MB blocks. So let's say 300 MB, and here is the last 30 dB or 20 MB kind of data. And the blocks are then placed into the individual data nodes. So all of you understand the rack and how the disk are placed on the racks and data centers. You know what is rack and a data center, right?
Yes. So Miraj, I'm still able to figure out what you're saying. Some lag on.
Okay. Okay. Just give me 2 minutes. Let me put on the broadband, the network cable rather than the Wi-Fi. Just give me a minute.
Sure.
or we can have a okay, it's told. Just give me 2 minutes. Can you hear me?
Yeah, it's much better now.
Okay. So yeah, Wi-Fi is always a problem. Okay. So what I was saying is, I hope you understand what is rack and what is a data center.
Yes, I do.
Okay, fair enough. So here is a picture of one of the cluster where I am assuming just I have a single data center which has three racks: rack one, rack two, rack three. Each rack has a 4 disks. So I have to put my file, which is of say around 300 MB. So that file will be divided into blocks. In Hadoop 1.x, the by default block size is of 64 MB, and in 1.x is by default is 128 MB. So here we are assuming 1.x cluster. The file will be divided into blocks, the 5 blocks which you can see on the right hand side in the green color. So how the blocks are placed, and how we replicate the blocks, and how the file is basically maintained in the cluster, or how the file is divided or distributed in the cluster. So the first block would be placed in some of the disk randomly. The another two copies. So as I told you previously, the file or the data is copied n number of times to maintain the data, basically reliability of the system. And by default, the replicant factor or the in the system is 3. Again, this is configurable. You can change the replicant factor, but by default is 3. So the first copy of the block is placed randomly in any of the data nodes. The second and third copy are placed in such a manner or in such a fashion that your uh, reliability of system is pretty high. So here you can see I have placed block 1 on disk 1. However, the copies of block 1 are next to copies of block 1 are placed on disk 6 and disk 7. And the reason behind that is the probability of the whole rack going down is pretty high as compared to two racks going down at the same time in the cluster. And similarly, probability of a single node going down is pretty high as compared to two different nodes going down at the same time. So I have the copies of first block of the file available at three different places. So even if the rack 1 goes down, I have two copies lying in the rack 2, or even if the rack 2 goes down, I have a single copy lying in the rack 1, or if the disk 6 goes down, I have two copies lying down in disk 7, disk 1, and so on. Similarly, second block will be placed up. So can you guess where the second block will go, or in which data nodes it could go? So let's say the first copy goes to disk 6. Can you guess where the second and third copy would go?
Should be on rack 1 somewhere.
Hmm. Can you give me a technically correct answer?
So I think it'll go to disk 11 and 12.
No, that's not the technically correct answer. Any other guesses?
1, 2. So it should not
Along with disk 1 and disk,
Sorry?
7. 1 and 7?
yeah.
No. So the technically correct answer is it would not go to rack 2. It can go to any other place. So again, it will try to reduce the failures, or it will try to make system as much reliable as much possible. So it will not place the second and third copy of block 2 to rack 2. It can place those things anywhere else. So it might place on rack 1 also, rack 3
Here I'm
also.
having,
Sorry.
yeah, I'm having one, like in case of first block number 1,
Hmm.
so we placed it disk 1, disk 6 is having 2. So I think technically it should have one in rack 1, second copy in rack 2, and third copy in rack 3.
Okay, pretty good question. Can you think of the answer? Yeah, that's a pretty good question. And I was supposed to ask that question in a minute only. So any guesses why not? Okay. So the answer to your question is see what happens is when I as a client I have to write some data. So I as a client would be sitting somewhere in the cluster. Let's say I as a client sitting on this disk. Okay, I have to write this file to the cluster. I'll contact to name node. Name node, this is my file which I have to write up. So this file has five blocks. Tell me where to write it. So what it does is it will first try to give you the nearest location where to write the block nearest to you. So as a client sitting on the disk one, it will tell me the okay, go boss. Both of you do you if I use sometime Hindi words in between, you understand Hindi?
I do.
Okay. Sometimes
Yeah, I do. I
okay.
do.
That's good. So most indeed I rarely use, but some of the times just so I just want. So basically, it will say, "Hey boss, I have to put it. I am sitting on disk one. Tell me where to write it." So first, it will try to localize reduce your data transfer, because data transfer across the network is pretty costly. So it will tell you go and write on disk one, the first block. Second and third block now need to be transferred over the network, and it cannot be placed on the same rack because I'm sitting over here and I've already placed one block over there. So second block will need to be copied from this rack to some other rack. Now the data transfer of the rack is much costlier as compared to data transfer in the rack, and the transfer speed in the rack is much higher as compared to the transfer speed across the rack. So this data need to be copied from this rack to this rack. Now to reduce the third network cost, it says I'll write both the blocks in the same rack and I'll divide into different disk, because two racks going down at the same time, that probability is pretty less. However, it can be the case, but it's pretty less. We try to reduce the risk as much as possible, as well as it try to optimize your network speed, network bandwidth, network uses, and fast writes. So if I have to copy this first block from here to this rack, again it would have been again slower. So it tried to reduce that thing and places on the same rack, however on a different disk. Does that answer your question?
Yeah, it does, but what about the second block? Like for second also the algorithm will behave same, right?
Second, the algorithm will behave same, yes. So it tries to localize as much as possible, but it's not always the case that you will your copy will be localized only. It might go to somewhere else. So I, as a client, might be sitting over here. It would have given it. So I'm just giving you an example. So where it's placed, first block will be placed randomly. It tried to localize as much as possible, but first block will be placed randomly in your cluster. Second and third would be placed on some other rack, but not on the same rack.
So, Miraj, if I can understand the algorithm, it has got two component. Um, can I say that back to you, what
Yeah,
I
yeah,
understood?
yeah, yeah. Please go ahead.
Okay, so this algorithm has got two factors. One is basically the data has to be written in different racks. So first it writes in disk 1 and then it looks for the nearest disk in the rack 2. So then it goes to disk 6.
No, no, no,
And
not.
then,
No, just let me correct you. Uh, or let me rephrase what you are saying. If you're saying the same, the first block or the first copy of the block is written anywhere in the cluster randomly. While writing up, name node takes care in the cases of those things that it will try to reduce the network cost and network bandwidth. So it will try to give you the node nearest to you to write your first copy of the block. Second and third are written to some other rack or some other data centers to reduce your to basically increase the reliability of the cluster. Now you can rephrase yourself.
sure. So what I'm saying is basically we assume that rack 1 and rack 2 are in two different networks, correct? Either it could be different subnet or basically a totally new data center. So
Data center, I have not still talked about. I'll talk about, but right now it's consumed. There's a single data center with three racks.
yeah, okay. So it starts writing in disk 1 and once disk 1 is done, then it has to go to the new rack. So it will go to disk 6 or any other four disk. So disk 6 or 7 or 8, whatever. So it writes there. Now, when it is writing the third copy, since it has already spread the data into two racks, then it doesn't feel the need of basically going to the third disk, third rack, because that is network expensive. So you go back and say that, okay, now you already have a data rack, you same rack. So it consolidates the data, first copy in rack 1 and copy 2 and 3 in the rack 2. This is
Yes.
for, okay, now coming back to the second block. So now when it has written the data, so the file, the right pointer is localized into disk 7, which is in rack 2. So when it reads the second block, name node will say that since you're already in rack 2, start writing the data in rack 2 itself, right?
So again, the first block, although it will try to localize, but the algorithm is random only. That first block, first copy of the block would be randomly placed anywhere in the cluster. That's what algorithm says, which is by default implemented. Again, it's configurable. You can change it, but it tried to localize, but again, it's randomly. There is no such guarantee that if you're sitting on rack 2, first copy will be placed on rack 2 only. But you try to reduce the
Okay.
network. It will try to reduce the network transfer or network transfer of the data as much possible as it can. So it might be the case that
Okay.
that all the four nodes are busy in some process. They do not have bandwidth to write out. So in that case, it will transfer your request to data node one, rack one.
Okay.
So name node has a picture of the total cluster, which node is doing, which node is having which data, which node is available in the cluster, which node is dead, all those things. So that things are also taken picture while it returns you where to write the data.
Okay.
So basically what happens is, this is how write happens. I've again switched back to slide number 47. So I as a client ask name node to write, that I have to add a block. Name node returns me the position where to write. I as a client then gives a write request to that data node. That data node, so this is the first block which is written to the data node, which was one in in our block one case. Then that goes to disk 6. That disk 6 then copies the data to disk 7. Disk 7 write gives me acknowledgement signal. This gives an acknowledgement signal to disk 1, and this gives an acknowledgement signal to client, and client sends a complete signal to name node. So
Okay.
that's where the network transfer happens, and that's where the network transfer happens. And that's where the rack transfer happened in the previous example.
So the one which you scribbled right now is the rack transfer, and then
Yeah, so this was your 1, and this was your 6, and this was your 7 for the block 1.
sure.
So this is because this copied from the data node to the other data node. So there's a network cost which is involved while copying this data.
Okay.
So make sense?
Uh, if that is okay with Pravijit and you,
Sorry?
can we take a 5-minute break?
Yeah, sure. Now, although this, how was the time right now? I think this class was 2 hours or 2.5 hours.
2 hours.
2 hours. Okay, sure. So it's almost, it would be 2 hours only, huh? Yeah, we are almost, would be, yeah. So we'll wind up in next 10 minutes. Is that fine?
Yeah, that's fine too.
Okay. Okay. So this is where the third block is copied. Now you can answer where the other two copies would be copied. It, it would go to either rack 1 or rack 3, but not to rack 2. And same thing happens if I have a different data center. So let's say this is my one data center. This is my one data center. And similarly, I had a data center somewhere else in the geography. So the one copy would be copied onto this data center, and another two copies might go to the other data center to reduce further geography kind of risk. Make sense?
Yes.
So this is what I was talking about. One replica on local node, second replica on the remote rack, third replica on the same remote rack. Additional replicas are placed randomly. It will try local, but it's not guaranteed. And when the read happens, name node intelligently return you the nearest data node where the data is lying up, and you read from that data node. I'll explain you how the read happens in later on also. So now this makes sense to you. Why, how the failures are taken care, how the system is fault tolerant. Make sense? Shall I go ahead? The replication factor is by default 3. The blocks are always copied 3 times. So Shekhar, you had some other questions. Were those answered in the previous slide, or any other question which you had open still? Looks like he's a little away. Shikhar there?
Yeah, I'm here.
So were all your questions answered, or is still any other open question previously which you had?
I'm just thinking.
Okay.
So, so one question which I still had was, so when you say block file write once, delete and if it is to be appended, it has to be deleted from this, right? So suppose, take that example that I have, say, my file is in 2 blocks, just to make the example simpler.
Hmm.
So with what you're showing here is, I have got 3 copies of 1 and I've got 3 copies of 2 in between rack 1 and rack 2. Uh, now, if I get new data, so taking the same example,
Okay.
so if I had,
So actually, in a single word, if I tell you na, is here you don't have basically kind of files. All your data lies into directories. So practically, whenever you add something, you just add some files into the directory, and that becomes your data. And so all your data is pointed to a directory always. Anytime you process something, you process directories rather than individual files, because your data is of pretty high sizes. And when I will show you the real picture, your data is your files names are not like shaker.png kind of thing. You have pretty big files, and the file names are created by the systems only. I'll explain you when the data processing happens. So that's what I'm trying to say. So you can't open this block and change it, because this block is copied on other two nodes also.
let me give one example, like it will help. So suppose
Okay.
if I had got 1,000 records in my employee table, right?
Mhm.
And I replicated this 1,000 records. Next day, I got 100 updates in my table on the same 1,000 records.
Mhm. Yeah. So
So will it go and delete those 1,000 records which it had earlier written into blocks and write a new block, or how does that piece will be handled?
so this is a dumb system. It's not like Oracle. I just say employee ID so and so, now salary is so and so. Yesterday it was so and so. You have to write your own program if you want to update those things. So you have to write your own program to figure out those 100 records, or basically to create a new file and delete the old files. In this system, you can just type two commands: write or read, nothing else. As a file
Okay,
system, you can interact write or read.
okay, I get it now. So basically what you're saying is um, the system is not intelligent enough to find out what it,
This,
so you just correct?
yeah, so this is not a database. This is a file system. You get files, you put your files, you reply logic on those files, you read the data from the files only, and you do the processing on files. This is not a database kind of Oracle or RDBMS kind of thing. However, there are
I get it.
technologies which are treating these files as an RDBMS word, but the system as a technology, Hadoop is not a RDBMS or basically Oracle or MySQL kind of thing.
Okay.
Make sense?
Yes.
Okay. Okay. So, okay, this was just 2 hours class. So I think yeah, we can wind up. Uh, acha, actually, previously this class was I think scheduled in the morning, but later on shifted to evening. So tomorrow I have a flight, and I'll not be able to take the class in the evening. Are you people available on someday on the weekdays? Can we have the tomorrow's class someday on the weekday, if possible?
Yeah, I am available this shaker.
Yeah, even fine with me.
So does similar time or half an hour prior kind of thing works? Because rather than 2 hours, let's have it 2.5 hours, because 2 hours class is very small.
We can
Yeah,
probably start at 8 somewhere.
Yeah, 8 or 8:30 kind of thing. So Shaker, it will be your, I think, right now it's
Yeah, I can start half an hour early, so 8:30 is fine.
so shall we have
And
it
one more
on
thing.
Wednesday?
No, Wednesday actually I'm flying. Wednesday is 23rd, right? I'm
Yeah.
flying to Pune,
Acha,
23rd morning, and I'll be
okay.
back Sunday, no, Monday morning.
Monday morning. Shall we have it on Wednesday, Thursday or Tuesday?
Yeah, I'm good.
Monday, Tuesday will be fine.
Monday again, maybe night by Friday. Sunday, we maybe night by Friday. Tuesday, I'm available in the night.
Say again?
Tuesday, I'm available in the
Tuesday,
night.
Tuesday I'm good.
Yeah, I'm
Same
also good
time, right?
Tuesday.
So, okay. So I'll send you a meeting invite for Tuesday, half an hour early, and we'll have 2.5 hour class.
Okay, thank you.
And these PPTs I'll share with you once we are done with the whole PPT. Basically, whole PPT. Then I'll share with you the PPT, and I'll also share you one link where there are different softwares which you can just download it. Don't worry about what all those things are. I'll explain you each and everything, how to download, how to install all those things. But you just download because those are heavy softwares, so that later on you are able to run it. And I think you are having a laptop with 8 plus GB or 8 around 8 GB of RAM or less than that.
Um, Mine is like I'm having one laptop with 8 GB, but that's my office laptop. I'll see if I can use that, but my this laptop is having around 6 GB, I guess.
6 GB is fine. So basically there are two versions of Hadoop which I'll be sharing with you. 2 point you can download 2.1 that uses the bare minimum. The 2.31 is using pretty high, so that requires 8 GB only. But if you have less than 8 GB, you can use 2.1. Higher than 2.1, if you have 8 GB or 8 GB plus RAM. So I'll share
Okay.
you the link. You can just download all those things. I'll explain you in the next class how to basically open it up and run all those things. Probably in the next class we'll be running only with the theory because there are a lot of things which are left. And so I'll see if we have the next time in the next class. Otherwise, next to next class I'll explain you how to install those things. But download will take time because that is around 20 plus GB kind of data, or 10 20 kind of 10 or 20 GB kind of data. Okay, so I'll share those links with you, and these PPTs again will be available to you on the drive. The recorded sessions, you can just drop an email. I'll let you know the email ID which you can drop out if you want an access of any of these recorded sessions. And if someday I forgot to record on your labs, on your GoToMeeting also you see that session is getting recorded. If someday you see that is not getting recorded, please remind me. Otherwise, the recording will not be available for you later on the time. Sometimes I forget and so I have to share then the previous classes which I've taken with other students. So any
Okay. And
comments?
one more thing.
Yeah, yeah, go ahead.
Next week, is it possible that can we postpone the class somewhere like after Monday, Tuesday, like weekday? Like
Prabeet, I am
might
open.
be like
I am open. I have no problem. We can discuss menu mutually, and if all three of us, if we are just
yeah,
three, then it's fine. I'll just check if just three of anyone is not there today. If just three of us, I have no problem. We can mutually coordinate, and we can have the classes.
fine. Maybe we can discuss Tuesday evening, right?
By the time I'll also confirm कि इस बैच में और तो कोई नहीं है ना.
ठीक है, ठीक है.
Okay, so I'm good. So still 4th of this month or 3rd, I think, whenever is the Sunday. I'm good with you having a weekday class if that works out for everyone because I'm off from my office. But after that, we'll have to restrict to
Weekend, yeah.
weekend.
Yeah, sure. So that will be mutually will everyone that will be suitable to everyone. Then only we'll have it. Otherwise,
Sure,
we'll have on the normal schedule only.
sure.
Please, please. So anything which you want to say? Any updates? Anything which you want to say? Prabjeet Shekhar. Anything else?
Thank you so much for your time and really good class. I really enjoyed it, and I think you got a lot of knowledge with Hadoop. We just have to extract it with the right questions. So I will try to do that.
Yeah,
So very
please
good.
keep on asking questions because I normally just go on with the flow, which I keep on speaking at different places. So, but yeah, definitely you keep on asking questions so that you will be able to get off. But basically, what I can answer, I'll always try to answer. I can't answer all the 100% things, but I would be try my best to answer all those things. If I'm not able to figure out the answer that time, I'll be able to figure out answer later on. I'll definitely try to satisfy your queries as much as possible. Yeah, but
Okay.
please keep on asking questions so that you are able to get the knowledge because I can just share the knowledge because all these things you can read from the books, but knowledge is what you can get from me. Prabjeet, anything?
As of now, I'm good to go.
Okay, sure. Then thanks for your time. Let's meet then on Tuesday, half an hour early. I'll send a meeting invite from my mail. That's miraj@designpathshala.com.
Okay. Thanks,
If you have
everyone.
if you have if you have any by any chance any changes or anything which got stuck up, just reply me on the same email. Thank
Sure.
you. Good night. Have a nice day.
Thank you. Thank you. Bye.
Thank you. Bye.